Now, before we get into today's notes, y'all turn to the page in your notes where it talks about proportions. Somebody tell me something about a proportion. Porter, tell me one thing.
They have to be a straight line.
They gotta be a straight line, good. Somebody tell me something else about a proportion. Joseph. Good. Straight line and go through the origin. Now somebody tell me the most important piece of the notes from proportions. Angel. That's not the most important, but that is also important. So I'll give you credit for that. But what's the most important thing, Asen?
K equals y over x.
Good. To find K, you need to divide Y by X. All right. So today, we're going to talk about direct variations. Which are also proportions. So somebody tell me what that means. Direct variations are also proportions. Right. So all the notes for proportions have to apply
Here.
today. Does that make sense? So we'll quickly touch on them. We've already done them. We'll just refresh the memory nice and quick. Okay, fast. All right. So we said it must go through the origin. Who is rattling papers? Why are you rattling papers? 2, it must be, how quickly y'all forget? Straight line. The equation, what was the equation? Y equals K times X. And the most important piece of proportions, which is also the most important piece of these notes, what is it? K is equal to Y divided by X. If you ever want to know what number K is, you got to divide Y by X. Now, today, they're going to call K something slightly different than we called it for proportions. Are you ready? Same thing, though. Are you with me? Who has a nickname? Anybody have a nickname in here? Joseph, what's your nickname? Joe. Joe? They call me Murph. My friends do. Are you with me? You can call me Coach Murph. James, what's yours?
Plywood.
What?
Plywood.
Why?
I can't catch the football.
That's not very nice. Start catching the football.
Yeah.
And then you'll be like stuck on glue. Then they'll call you glue because you catch everything. Yep. Anyway, today K has a different name, but it's the same thing as we had for proportions. For proportions, we called it the constant of proportionality. Are you with me? Today we're going to call it the constant of variation. It's the same stuff. Different name. Any questions? So today on the homework, if they talk about this constant of variation, they're really asking you what is K. That's the only thing they can ask you pretty much. All right, let's do a couple of problems. They won't take long. Let's start with the table. They might ask you, is this table a direct variation? Somebody raise your hand and tell me how we can quickly come up with a yes it is, no it is not. Tucker.
Do y divided by x.
My man. Y divided by x. Let's go. What's 14 divided by 3?
4.6 repeating.
All right, as long as we get 4.6 every time, we're good to go. What's 18 divided by 6?
3.
Did we get the same number?
No.
No.
Is this going to be a constant or a direct variation?
No.
Y divided by x did not give me the same number over and over and over and over again. What if they give me some ordered pairs? And ask me, is this a direct variation? What can we do, Jinx?
Can divide 5 by negative 5.
Divide y by what?
X.
Or did you say 5 or y?
5.
Ooh, I don't like that. X divided by y makes you cry. Let's not cry this morning.
Let's pass the test.
Yeah, so what do we need to do, Jinx?
Y around the X.
All right, so what's negative 25 divided by 5?
Negative
Negative 5. What's negative 30 divided by 6?
Negative 5.
I think we're on to something. What's negative 35 divided by 7?
Negative 5.
Is this going to be a direct variation?
Yes.
Yes, it is. All right, what would the equation be? Who could help me write the equation for this direct variation? Somebody besides Porter. Porter's already out. Tucker's already out. Jinx is already out. Somebody new. Crosby.
Y equals negative 5x.
My man. All you gotta do is replace that with negative 5. Y equals negative 5x would be the correct equation. All right, and what if they said, hey, if x equals 17, what would y be? How could we figure out what y would be if x is 17? Do I get to think? You've already helped me. Put your hand down. You're done. Let's go with Asen. What would you do if they said, hey, x is 17, what number would y be? Use that equation. Well, let's read the equation. This equation says y equals negative 5.
X.
What does that mean? Negative 5x. No. Don't do this yet. We're reading this. What does this equate? Here's the problem with kids. Y'all just look at that and you're like, oh, that's the equation. You don't understand what it means. Here's what it means. Watch. It's easy. Y equals negative 5 times x. Negative 5 times x. Don't they tell me what number x is?
Yes.
Oh, it's easy. Yeah, that's what you got to look at that equation and understand that says y equals negative 5 times x. When I give you an x, what do we obviously do with the 17 and the negative 5? We multiply. Because the equation says multiply x times negative 5. Are you with it? That's where you start to understand math, kids. Instead of just trying to remember, oh, the stupid equation is y equals kx. Well, that really means y equals k times whatever x is. Does that make sense? So now it becomes obvious. Angel goes, oh. And you're right, Angel. All we got to do is multiply 17 times negative 5. What did you get, Xavier?
Negative 5.
Well, wait. Type it in.
Negative 85.
Bingo. Y would need to be negative 85. Questions? All right, one more, then we're done. What if they didn't give me x, they gave me y? If y is negative 150, how could we figure out what in the world x would be? Angel.
Don't you divide negative 5
Yeah, you would need to divide negative 150 by 5, negative 5. So if they give me y, are we going to multiply?
No.
No, we only multiply x times negative 5. Are you with me? When they give me y, we got to do the opposite of multiplying, which is divide by negative 5. What is negative 150 divided by negative 5? Brock.
30.
30? So x would have to be 30 if the answer was negative 150. Questions? And that's all there is to it, Kay.
Yay.